Welcome to the Beef and Lamb New Zealand Genetics Project, looking at the trait of feed efficiency in sheep. This is also partly funded by Ag Research, who have organised for the feeders to be built out here. So the trait of feed efficiency in sheep, it's kind of been a trait that we've always wanted to have a look at, but we've never been able to have the money or time or resources to actually start looking at it. But in 2015 this facility was established, and we have 20 feeders here that are capable of measuring 200 animals at a time. The idea of feed efficiency, and I'll talk through it more as we start looking at what we measure with these animals, is that some animals need to eat more or less for their productive outcomes. So if we think of two 45 kg animals that are growing about 250 grams a day, both very similar, do they need to eat the same amount of feed to have their production outcomes? And the answer we found from last year's trial is the answer is no. So what we do here at the facility is that we have sourced animals from the Beef and Lamb Genetics New Zealand progeny test, the CPT, and also John McEwen's progeny test down at the Coopworth progeny test down at Woodlands. So we have about 8 to 10 progeny from each of the sires that are as part of those tests. And they come up here and they go through a 2-week adjustment period, and then they start in the real trial for 6 weeks, and during that time period we weigh them twice a week, and then we look at their live weight gain during that time.
So I'm Kevin Noller. I'm the Farm Operations Manager at Infome, and I've also had a lot of dealings with this RFI facility since we started a year ago. And so we did a lot of prototype work, and we've come up with this feeder here now that our team at Lincoln, Agriculture Lincoln came up with. The animal walks in here, and it passes a light beam here. So as it passes the light beam, that starts to trigger a feeding event. It then puts its head through the keyhole, and it starts to feed. And they've all got electronic tags, so the animal will then be reread. And after it finishes feeding, the animal then backs out past the light beam, and that finishes the feeding event. And it then records how much it ate during that event. It records how long it ate and how much it ate during that event. Then when it needs to refill, there's a door comes down, and it refills itself again and then opens up again so the next animal can feed.
We can get an accurate intake that they're having each day, and then work out what their intake is relative to what they should be eating for their live weight gain and their live weight. So when we did the equivalent trial last year, we found that for any 2 animals that there was almost a 24% difference between high efficiency and low efficiency animals, such that the inefficient animals were eating 24% more than they ideally should have needed to have eaten compared to their high efficiency contemporaries. So when we're thinking about this trait of feed efficiency, we really need to have information on how much these animals are feeding, and these feeders have been set up and designed to be able to tell us that type of information. We also are interested in finding out different bits about how the animals actually behave, and this type of information really easily comes out from this particular trial as well. Because we're getting real-time feed intake information, we know how often these animals are actually going into the feeders, and we know how long they're staying in there and how much they're eating on any given event. Last year when we did the trial, it was quite interesting to see that some of the animals were going in up to over 40 times a day and just having really little feeding events every time they went in, whereas some of them were going in only 15 times a day and having really large feeding events every time they went in. So there was quite a lot of difference in how these animals were actually their grazing behaviours. One of the questions that we always get asked out here is, well, what are we feeding the animals? One of the key things that I was aware of in setting up these trials was that we did not want to be feeding them a grain-based diet like some Australian contemporaries are doing with some of their similar trials, because I knew that standing talking to farmers, the first reaction would be, well, that's not what we feed our animals. So what we're feeding them is a lucerne-based pellet. Actually, it's 100% lucerne pellet that we're sourcing from Australia, so it's a pure forage pellet. The ME is about 10.4 megajoules, so it's really equivalent to what they would be eating. The girls out here are growing lambs, so one of the other questions that does come through with this type of work is, well, is feed efficiency in the growing lamb the same as feed efficiency in an adult sheep? To do this, we have undertaken some pilot studies up until this point. We followed a group of about 40 animals through as growing lambs, and then 23 of them we repeat measured after they'd had their first lambing. While the same trait of feed efficiency wasn't completely apparent, what we did observe was, because we are taking fat measurements at the start and the end, what we were able to observe, and it wasn't a perfect correlation but significant evidence, was that lambs that were efficient as growing lambs were able to retain themselves when we started to give them a meadow hay pellet instead of the lucerne pellet as adults, so kind of mimicking what an adult sheep is having in that post-weaning period. Whereas the animals that had been inefficient as growing lambs, when we put them onto that kind of low quality pellet, is that they actually started to lose weight and lose a bit of body condition. So it really does fit with this idea that different animals can handle that kind of summer period post-weaning differently, and that it may well be related to their feed efficiency.
It takes about two weeks to get them adjusted on. Some animals will adjust almost immediately. So because it's a lucerne pellet, there's no issue about adjustment period. They go straight onto it, but there's a period where we're going to try and train them to actually get into the feeder. Some animals just go straight in. By the end of the first week, we get reports every single day about how many animals, how much they're eating every day. So we can identify very quickly the animals that might not be feeding. So we can separate them out, put them in a smaller pen, and we can adjust them by just pushing them into a feeder. And there's very few of them don't learn within the first week how to feed. Might just get one or two shy feeders that we might end up pulling out of the trial. In terms of weighing, we've got a automatic setup down below that we can weigh them twice a week. In fact, they're getting very good now at just walking straight through and get their live weight collected. Gut fills is quite a big issue, so we have weighed them empty at the start of the trial. We then weigh them full. We weigh them every twice a week, so we'll get over 12 weights on them over the 6 weeks. And then we'll weigh them again empty as well, so we can get a bit of an idea of what their gut fill is at the end of it.
Some of the other things that we're doing is at the end of the trial they do all go through the spiral CT scanner that's at InfoMay, and what this is looking to tell us is that we know, and from the preliminary work we've been doing, is that we can have two animals standing side by side, is that they can have quite different variation in how fat they are, but also critically where they've actually laid down that fat. If we think about a dairy cow versus a beef cow, dairy cows, to look at them, they look like skin and bones, but we do know that they've actually laid down a lot of their fat internally around the kidneys, internal fat, whereas a beef cow is more able to lay down that body condition subcutaneously over her back. And so the preliminary work we've done with our sheep over the last couple of years has also showed that we've got similar variability, and that some of our sheep genetics is able to lay down more of its fat internally versus externally. So we're hoping to get a lot more information on that as well as we go forward with this trial. One of the questions for the farmers is that we know that it's going to be impossible to take this particular trait out to the greater industry as a trait, because we're not going to be able to bring enough rams through this facility into the future. And so the idea is whether or not we can actually have biological predictor traits that we could actually take out and more routinely assess in industry. To do this, we have looked at things like heart rate, by putting a heart rate monitor on the animals when they go through the portable accumulation chambers to look at greenhouse gas emissions, and also looking at the thermal temperature of the animals, taking a thermal image of the back of the ear. What the hypothesis with this is that more efficient animals are going to have a different metabolic rate, and as such have potentially a lower heart rate, and maybe a lower heat, ridding themselves of heat effectively. So we did some work with the first 200 girls last year, and we do see evidence of a relationship that fits with those expectations. It's going to be one of these things that it's not going to be a perfect correlation such that we can go out and draft any given lamb as having a high or a low heart rate, or a high or a low back of the ear temperature. But if we look at a per sire line where we've got 8 progeny per sire, is that we can start to build up relationships at that genetic level. So we're very early stages, but over the next year or two, we're hoping to ultimately get about 1,000 animals through this facility and be able to really look at that relationship between, or confirm, which we think it should be from overseas studies, that this trait of feed efficiency is heritable and a moderately heritable trait, but also look at its relationship with other production traits like puberty, growth rate and all of those kind of things. But with the idea that hopefully we might be able to breed towards more efficient sheep into the future.